Hi everyone, this is Emmanuel from Ethiopia. Today I've built a brain tumor classifier and it tries to classify three kinds of brain tumors, a glioma, meningioma, and pituitary, and of course no tumor. So we give it a brain scan and it will try to classify it among these three. So for example, in this case, I have uploaded a test image which is no tumor, and it's both of my machine learning models have classified this as no tumor perfectly. So we can try a meningioma, like for example for this one. Let me upload it, and it's going to be classified as meningioma. Uh, let's see, let's wait a little bit. Yes, so it's being classified as meningioma by both models. This one is a model that's pre-trained by exception, and then it's called exception. And I have fine-tuned it to be able to detect these three tumors. This one is a custom-built convolutional neural network, and it's much smaller compared to the exception. So it's also less costly to deploy as well. And right here we can see that we have the saliency map for exception, which is this one. So we can see where the model is focusing to determine whether it is which tumor it is, and it's focusing on the right point, which is around here, and which is the tumor located, where the tumor located. And this is the saliency map for the custom CNN, and we can see that it's a little bit scattered. And down here we have an explanation of the image for the saliency map, which is generated by Gemini 1.5 Flash, and it's going to explain to us what's visible on the saliency map and why it's classified as uh, being meningioma with this percentage accordingly. So this takes both the saliency map, all the information that we had before, and tries to explain it for us why that's happening. We can also change this to explain for us for the custom build convolutional neural network, and it will do that as well. We can also change the role and the terminologies that are being used when generating this explanation by changing here. We can also ask questions like what's happening in this image right here. So what's important in this saliency map? And if we ask it, like for example for exception, this question, it's going to include the answer for this question. So let's wait for it. And down here we have our a report, which is basically tells us what's the next step for the patient, conclusion, and also additional insights that we might want to consider. So right here, for example, what's important in the saliency map? It says the most important aspect of this saliency map is concentrated area of attention with the right parietal lobe, right? So it keeps explaining to us what's the important thing and so on. So this is like a very useful thing for us so that we can understand why it's also being classified as it's being classified, right? And down here this is a report, and over here you can see that the accuracy of the models that I have trained, like we have 99% accuracy for the exception model, and then we have 98% accuracy for the custom built convolutional neural network. And for this, this one was trained, but I'm not using it because it have a low accuracy, like 94 accuracy, so I am not using it right now. And then we have confusion matrix, which is for the custom neural network, so that you can see like some of the visualizations I used during the work here. I'll be sharing the GitHub link in the description so that you can follow that and look into the code more in depth. Thank you for listening to me.